You know, right now, as you're sitting there, a war is being fought inside your body. It is a silent, completely microscopic conflict where the stakes could not be higher. We're talking about your health, your life. So let's dive into the incredible story of this elite cellular army that keeps you alive, your white blood cells. Just imagine it for a second. A nasty virus or some harmful bacteria manages to slip past your skin, your first line of defense. Instantly, the alarm bells start ringing, and this unbelievably sophisticated response just kicks into high gear. An entire army gets mobilized in the blink of an eye.
And get this is the size of that army that's just always on standby. In a single tiny cubic millimeter of your blood, that's a space smaller than a pinhead, you've got somewhere between 4,000 and 11,000 of these defenders. Their formal name is leukocytes, which literally just means white cells, and they are big, they're mobile, and they are always ready to fight. Okay, so having an army is one thing, right? But getting it to the right place at the right time is a whole other challenge. These cells have an incredible set of skills that lets them leave the superhighway of your bloodstream and travel right to the heart of an invasion.
This is how they do it, in this remarkable four-step process. First, they perform something called diapedesis, which means they literally squeeze themselves through the tiny gaps in your capillary walls. It's wild. Then, they use ameboid motion to crawl through your tissues, kind of like a microscopic slug on a mission. And how do they navigate? Chemotaxis. They're following a chemical trail of breadcrumbs left by the invaders. And once they arrive, well, that's when the main event starts. Phagocytosis. The attack begins. The word phagocytosis itself is so cool. It literally translates to cell eating. And that's exactly what it is. It is the main way these soldiers take out a threat, by swallowing it whole, digesting it, and then just spitting out the harmless waste. It's a brutal, but man, is it an effective tactic. And this isn't just some random gobbling. No, it's a precise, multi-step operation. First, the enemy gets tagged for destruction, a process called opsonization, which basically makes it extra tasty for the phagocyte. Then, the cell latches on, engulfs the invader in this little bubble, floods that bubble with powerful digestive enzymes, and finally, just spits out the harmless remains. Job done. Okay, so we know how they fight, but who exactly are these soldiers? Well, the first ones to arrive on the scene are a group called the granulocytes. They get their name from these tiny granules in their cytoplasm, the jelly-like stuff inside the cell, which are just packed with chemical weapons. This chart gives us a peek at the Army's roster. And you can see right away, one type just absolutely dominates the ranks, making up about 65% of the entire force. These are the neutrophils, and their sheer numbers tell you just how critical they are. They are the absolute backbone of your initial immune response. So all your white blood cells fall into one of two main squads. You've got the granulocytes, who we're about to meet, carrying those prepackaged weapons, and then you have the non-granulocytes, who show up a bit later and fight with different tactics. It's a simple distinction, but it really defines their roles in the battle. All right, first up, the most numerous of them all, the neutrophils. Think of these guys as the fearless infantry. The second a bacterial infection is detected, your bone marrow just starts pumping them out in massive numbers, and they swarm to the site of the invasion. And they are incredibly good at their job. A single neutrophil can take out anywhere from 3 to 20 bacteria before it dies in the process. They're your primary defense against all those common pus-forming bacteria. Their little granules are filled with proteases, enzymes that are experts at tearing proteins apart. But that's not all. They can also create powerful chemicals like hydrogen peroxide. This creates this deadly killing zone right around the cell, so they can destroy invaders without even having to swallow them. Next up in the granulocyte lineup, we have the Eosinophils. Now, these are your highly specialized commandos for dealing with much larger enemies, like parasites. You don't have a lot of them hanging around normally, but the second a parasitic infection kicks off, their numbers just skyrocket. They'll attach to the parasite and just unload their toxic granules to destroy it from the outside. And finally, we have the rarest of the granulocytes, the Basophils. These cells are the sentinels, the ones who sound the alarm. They don't usually eat invaders. Instead, their job is to kickstart the entire defensive process. So what makes them so important is what they're carrying. When they get activated, they release histamine, which triggers inflammation. That makes your blood vessels leaky, which sounds bad, but it's actually helping other white blood cells get to the battlefield faster. They also release heparin to make sure blood clots don't block the way. And this is also why they're the main culprits involved in allergic reactions. So, after the first responders, the granulocytes, have engaged the enemy, it's time to call in the second wave.
These are the specialists, the ones without granules. We're talking about the heavy hitters and the master strategists of your immune system.
First of these are the monocytes. These are the largest of your blood cells, and while they start out in the blood, that's not where they do their most important work. Think of them as professional cell eaters in training.
Their life cycle is just fascinating. They'll circulate in your blood for a few days, and then they'll migrate out into your body's tissues, places like your liver, your lungs, or even your brain. And there, they go through this incredible transformation, maturing into these massive, powerful, long-lived cells called macrophages, which literally means big eaters.
And that brings us finally to the very core of your immune system, the lymphocytes. Look, if neutrophils are the infantry and macrophages are the tanks, then lymphocytes are the intelligence agency and the special ops team all rolled into one. They provide a specific, highly targeted defense.
Lymphocytes have two main branches. You've got B lymphocytes, who are like the weapons developers. They learn to create these custom-made proteins called antibodies. Now, antibodies don't kill anything directly. They act more like homing beacons, tagging invaders for destruction. Then you have the T lymphocytes. These are the assassins. They handle the inside jobs, seeking out and destroying your own cells that have been compromised by a virus or have turned cancerous.
So after the granulocytes rush in, the macrophages clean everything up, and the lymphocytes execute their precision strikes, the battle is won. But what happens next is just as important as the fight itself.
And this really highlights just how incredible this whole system is. It's not just about fighting off bacteria. Your T cells are constantly patrolling for cancer, recognizing abnormal proteins on tumor cells, and eliminating them before they can ever become a problem. It's basically your body's own internal cancer therapy running 24/7.
Once the threat is gone, most of the cellular army undergoes what's called apoptosis, or programmed cell death, basically to conserve resources. But, and this is the most crucial part, some of those specialized B and T cells don't die. They become memory cells, the veterans of the war. They stay on the troll for years, sometimes for your entire lifetime, making sure that if that same enemy ever shows up again, the response will be devastatingly fast and overwhelmingly strong. This elegant system of memory is the entire reason we have immunity and why vaccines work.
This cellular army is truly one of the most complex and effective systems in the known universe, protecting you every single second of every day. But it's so incredibly powerful that when it does make a mistake, when it misidentifies its target and mistakes friend for foe, the consequences can be devastating. And that raises a whole new chilling question about the dark side of this powerful defense.